Hi, welcome to tighter bound running time calculation session. Here f of n equal to 8012 equal to proof that it is theta of n. So given constant function f of n equal to 8012, we can ask this question here, show that 8012 equal to big theta of n. Here you find C1 constant 1 and constant 2 and initial input size n0. For computing the tighter bound, we are having the criteria 0 less than or equal to C1 into G of n, and here less than or equal to f of n less than or equal to C2 into G of n. C2 into G of n. This is the given criteria of a tighter bound. You look at that from this figure, C1 into G of n is less than or equal to f of n less than or equal to C into G of n. So for example, n0 equal to n0 n equal to 2. For example, n equal to 2. For this, you look at that this point C1 into G of n less than here f of n. This one is C2 into G of n. So like this, it should satisfy the condition for giving input size for given function f of n. So here already f of n is given 8012 constant function. So f of n is substituted in this location. So f of n is 8012. Then C1 is, I am taking smaller number or equivalent number than the given f of n. F of n is 8012, so I am taking the smaller number. Here the function is constant, so I am taking the constant function 1, right? And here C2 is, I am taking greater value than the 8012, so I am taking 8013. Then given G of n is the 1, because I am taking the constant function 1. So from this we can say C1 is 8011 and C2 is 8013, and given function G of n equal to 1. It will be true for all n greater than or equal to 1. Suppose if you are taking the constant function 3, constant function 3. So when you are taking the constant function 3, when you are substituting here 3, that is also will be here 8011 into 3 here, which is not satisfying, so we cannot take the 3, right? We cannot take the 3, so only we can take constant function n equal to constant function g of n equal to 1, constant function g of n equal to 1. We cannot take beyond that. But when you are taking 3, this constant value will be reducing. When you are taking 3, this constant will be reducing, so the C1 will be different. So when you are taking g of n equal to 3, then your C1 will be different. So you will get different kind of pairs C1 comma C2 for given function g of n. So that is the thing. There is the possibility of infinity number of inequalities, such terms. So another example here, 8012 is the given f of n, then I am taking the smallest number as a constant for given g of n is 1, and here I am taking the 9000 is the C2 and g of n is 1. So this is also true based upon the tighter bound criteria. So here I am taking very smallest number C1 and for given function g of n 1, and here 9005 is the C2 given function, the constant function 1. So this is also true. So based upon the given function, constant function, the C1 C2 also varying. So from this, what can we define? F of n equal to big theta of g of n equal to big theta of n for given the constant C1 equal to 8011, C2 equal to 8013, the input size n0 equal to 1, right? So like that for this one. Okay, for the second example, this one, C1 equal to 50, C2 equal to 9000, n0 equal to 1. Like that we can identify different such terminology C1, C2 values and also n0 value. Thanks for watching.